Good afternoon. My name is Clemente. Yeah, BSIP2. Today, this video tutorial, we're going to talk about 3D algorithm. So, what is 3D algorithm? 3D is an algorithmic paradigm that builds up a solution piece by piece, always choosing the next piece that offers the most obvious and immediate benefit. So the problem with choosing locally optimal also leads to global solution like the best fit for grid. Also, a greedy algorithm is an approach for solving a problem by selecting the best option available at the moment. It doesn't worry whether the current best result will bring the optimal result. The algorithm never reverses the earlier decisions even if the choice is wrong. It works in a top-down approach. This algorithm may not produce the best result for all the problems. It's because it always goes for the local best choice to produce the global best results. However, we can determine if the algorithm can be used with any problem if the problem has the following properties. 1. Greedy choice property. If an optimal solution to the problem can be found by choosing the best choice at each step without reconsidering the previous steps once chosen, the problem can be solved using a greedy approach. This property is called greedy choice property. 2. Optimal subtraction. The optimal overall solution to the problem corresponds to the optimal solution to its subproblems. Then the problem can be solved using a greedy approach. This property is called optimal subtraction. Advantages of greedy approach. The algorithm is easier to describe. This algorithm can perform better than the other algorithms, but not in all cases. Drawback of greedy approach. As mentioned earlier, the greedy algorithm doesn't always produce the optimal solution. This is the major disadvantage of the algorithm. For example, suppose we want to find the longest path in the graph below from root to leaf. Let's use the greedy algorithm here. For example, suppose we want to find the longest path in the graph below from root to leaf. Let's use the greedy algorithm here. So in this example, we're going to apply the greedy approach to find the longest root. Greedy approach. Let's start with the root node 20. The weight of the right child is 3, which is this one, and the weight of the left child is 2, this one. Our problem is to find the largest path. The optimal solution at the moment is 3, because 3 is greater than 2. So the greedy algorithm will choose 3. So finally, the weight of an only child of 3 is 1. This gives us final results. 20 plus 3 equals 20 plus 3 plus 1 equals 4. However, it's not the optimal solution. There is another path that carries more weight. 20 is the longest path we have. The 20, we start from 20 plus 2 plus 10 equals 32, which is the longest path. So therefore, greedy algorithms do not always give an optimal solution or best choice. Next, example of greedy approach problem. You have to make a change of an amount using the smallest possible number of coins. Amount $18. So the available coins we have are the $5 coins, $2 coin, and $1 coin. there is no limit to the number of each coin you can use. So the solution is to create first you can create this an empty solution set like this, curly bracket, open and close, and insert the available coin, which is this, the $5, the $2, and $1. We are supposed to find the sum of $18. So let's start with the sum of 0. So always select the coin with the largest value until the sum reaches 18. So when we select the largest value at each step, we hope to reach the destination faster. So the concept is called greedy choice property. In the first iteration, solution set equals open and close curly bracket, 5 and the sum equals to 5. In the second iteration, solution set equals to 5, 5, and the sum is already 10. In the third iteration, solution set 5, 5, 5, and the sum already equals to 15. So in the fourth iteration, solution set 5, 5, 5, and 2 and equals 17. So we cannot select 5 here because if we do so, the sum 20, which is greater than 18. So we select the second largest item, which is 2. Similarly, in the fifth iteration, select 1. Now sum equals 18 and solution set equals to 5, 5, 5, 2, and 1, which is 18, of course. Next is the activity selection problem. The activity selection problem is an optimization problem which deals with the selection of non-conflicting activities that needs to be executed by a single person or machine in a given time frame. Each activity is marked by a start and finish time. Greedy technique is used for finding the solution since this is an optimization problem. Activity selection problem example. Let's try to trace the steps of above algorithm using an example. So here we have a activity which has a starting and finish time. It's activity table. First step is to solve base and finish time. So, alright. Okay. This is the sorted table. Sort the activities according to their finishing time. So this is the sorted table. A1 to A3, A2, A1, A5, A6, and A4. And also the number here, the finish line is also sorted. So step 2 is to select the first activity from the sorted array and print it. So we print the first activity, which is A3. So let's take an example of having 6 activities. So this one, the A1 to A6, and then sorted based on finishing time. So note how this finish time row is sorted. So once we have this, it's time for the step 2. This is step 2, that is to print the first activity of our sorted table. So here we have the A3 already printed. So next, we will look all activities starting from A3. So since So, our explanation is that. So, we will continue in the all activities starting from A2. So, since the A2 is after finish the time of A3, so we add it to our answer. Yes, 4 is greater than 2. Next, we have the A1. Since the start of A1 is less than the starting is A1 is less than finish time of A2, so we're going to skip it. Then since we're going to A5, since we skip A1, we're going to A5. Since the start time of A5 is which greater than the previously done activity A2, we break this activity. Then next we have the A6. Since the start time of A6 is greater than the finish time of A5, we print this one. Next we have the last one, A4. Start time of A4 is less than finish time of A6. So we skip it. Let's skip the A4. Since there are no more activities left for answer. So there are no more activities left. Our answer would be this for activities in order. Yeah, that's it. That's how you solve activity selection problem. Yes, solve them based on their finishing time. That's it. Thank you so much for watching. See you next time. Bye bye.